In this question, we'll apply concepts of Newton's second law and also something that you have learned in a previous chapter, how acceleration affects motion. So the answer to this question is D, and this is the reasoning behind. These are four very important points that you should know, and you can apply this to all motion questions. So the four important points or these four premises are as such. Number one, the resultant force will make the object accelerate. So if there's a resultant force, that the object must accelerate or decelerate. It must either speed up or slow down. Second point is a very hidden but very useful point, that the direction of acceleration can be identified very easily because it is the same as the direction of resultant force. In this scenario, when there's a backward force acting on the car, that is the resultant force direction, and the acceleration direction on this car is therefore also backwards. The third and fourth point relates acceleration to velocity, and this is something that I shared with you in the chapter on kinematics. Very hidden point also, but very useful. So when the direction of motion and the direction of acceleration is the same, then the object must speed up. Okay, when the direction of acceleration is opposite to how you're moving, then the object must slow down. So in this case, how do we apply this? The car is moving forward, and then there is a backwards force acting on it. A backward force means a backwards resultant force, and this means that the acceleration of this car is backwards. If you realize, then the backwards acceleration on this car, and this car is moving forward, means that these two directions are opposite. The fourth bullet point actually applies. The car must slow down, and intuitively, if we visualize this happening, we also know that when the car is moving and when there's a backward force suddenly acting on it, you must slow down. Okay, so in animation form, this is what is happening. The car is originally moving at a constant speed, then suddenly there's a backward force, and look carefully at the words. So the backward force results in a backwards resultant force, results in a backwards acceleration, and because the acceleration is backwards but the velocity is forward, these two arrows are opposite in direction. We use the third point below and conclude that the object must slow down, which tallies with what we see. Now, when this backward force continues to act, which is what the question says, then what will happen next is this backward force will therefore push the object backwards, and this is what you will see. Okay, so the car will then be pushed backwards after it comes to a stop, and the acceleration direction is backwards, and the object is moving backwards. These two directions is the same, and therefore the object must speed up backwards.